But the pollutants that we are going to talk about today are called short-lived climate pollutants, something that stays in the environment for few days to few years, and what the world is doing about these pollutants. But it's very also important to understand the politics of these pollutants. Let me give you some idea why some gases are called long-lived and some gases are called short-lived. Already said, carbon dioxide remains in the environment for more than 1,000 years. Some 20% of the CO2 emitted somewhere in 1100 will still be in the environment. Half-life is about 100 to 150 years, 20% will remain for millennia. And every gas, global warming potential, it means how much global warming they can cause, is benchmarked with carbon dioxide. And therefore, global warming potential of carbon dioxide is considered as 1. Okay. Next is methane. It remains in the environment for about 12 years. There is a little bit of dispute on the science of methane, whether its global warming potential is 21 or 28. Okay. So that is there, but generally it is now accepted as 28. You have nitrous oxide, but you have black carbon. And I'll tell you what black carbon is. Delhi is being polluted by black carbon. All the pollution that you see in Delhi is actually black carbon. They remain in the environment for 3 to 8 days, but they cause warming, but there is uncertain science on how do we compare global warming potential of black carbon with carbon dioxide. That is not clear. We know they cause warming. Then there are halocarbons, from chlorofluorocarbon to hydrofluorocarbon, everything that we use in our refrigerator and air conditioners, refrigerants. They are super greenhouse gases. For example, the greenhouse gas of the popularly used refrigerant today in our air conditioners is at least 2,000 times more than carbon dioxide. Global warming potential of HCFC, which we now use, is about 2,200 times more than carbon dioxide. Then we have perfluorocarbons. All the plasma television that all of you have in your house are actually etched with perfluorocarbons. So we get your mobile phones. They all are cleaned and etched with perfluorocarbons. They stay in the environment for 50,000 years. Environment cannot break it. It's such strong compounds. And their global warming potential is 6,000 times to 9,000 times more than carbon dioxide. The only saving grace is that we emit little less of them compared to carbon dioxide. Otherwise, if we start emitting more of halocarbons, perfluorocarbons, and SF6, when we produce aluminum, this fluorinated compound is released, which is 24,000 times more powerful than carbon dioxide. So people do talk about carbon dioxide, but there are a lot more gases than carbon dioxide who cause climate change. And the red are methane, black carbon, halocarbons are considered as short-lived climate pollutants because their life is less than 10 years. They remain for less than 10 years in the environment. Now, why short-lived climate pollutants are becoming powerful? And I want you to focus for 1 minute on this graph because it's a very important graph to understand the science and politics of climate change, especially with respect to SLCP. Now, if we don't do anything, we are looking at 2.53 degrees temperature rise. Okay, so this line that you see here, the straight line, okay, if we only do carbon dioxide, we are still looking at more than 2 degrees. Do everything to control carbon dioxide. Okay, red line, we are still looking at 2 degrees. But if we take carbon dioxide, black carbon, methane, halocarbons together, we have a chance of hitting between 1.5 to 2 degrees. This is a hypothetical scenario. It tells you the importance of black carbon, importance of methane, importance of halocarbon in solving climate change. Only by addressing carbon dioxide, we are not going to solve the problem of climate change. So the basic idea yesterday you get that energy is important. Energy sector is very, very important sector, but so is other sectors of the economy where short-lived climate pollutants are produced. Methane, black carbon, halocarbons. So the world will have to not only address the issue of carbon dioxide and energy, we will also have to look at the issue of carbon dioxide, methane, black carbon. halocarbon, then only we will be safe. And therefore, black carbon, methane, halocarbons are important part of addressing climate change. From where black carbon comes, this is an interesting graph that tells you that what we call as survival emissions, okay, poor cooking food on biofuels, cooking food on coal, okay, brick kilns, industrial coal, open burning of agricultural field. Delhi right now is being polluted by burning of agricultural field in northern part of the country, okay. They all are black carbon, major sources of black carbon. Okay, this is what black carbon is all about. Black carbon is about burning of organic waste and agricultural field, cook stove, diesel vehicles, industrial coal plants. These are the sources of black carbon. Methane, if you look at it, one of the big contribution of methane is actually emissions when we produce fossil fuels. Methane gets emitted from coal mines. You'd have heard the story of cannery in the coal mine. That was to detect methane. Okay. You will have methane coming out from gas wells. US right now, the methane emissions are increasing because they are using fracking to produce natural gas. Methane emissions are increasing. Then you have livestock enteric fermentation, livestock manure, rice cultivation, agriculture. These all are agriculture sector emissions. But you also get methane from municipal solid waste. Okay, when we dump everything of our cities, especially organic waste, they decompose and methane is emitted. From wastewater treatment, these are urban waste management issues. So this is where methane comes from. Oil and gas, burning of solid waste, coal mines, agricultural field, and then hydrofluorocarbons and other halocarbons. Now think about the tragedy of science. In 1980s, the world decided that we need to stop ozone hole. I hope all of you have understood. There was a hole and that hole was causing cancer in the northern hemisphere, skin cancer, right? So they said that we need to get rid of chlorofluorocarbon. And we came through a convention called as Vienna Convention and a Montreal Protocol to get rid of chlorofluorocarbons. But the substitute of chlorofluorocarbons were gases which causes global warming. So it's almost like jumping from one frying pan to another one. We tried to stop ozone hole, but we are now causing global warming. So now we are saying, oh, we did a mistake. We now need to get rid of the substitute of chlorofluorocarbons as well. Okay, and that's what actually yesterday night till 4:30 in the morning, there was a group of negotiators in Dubai discussing to amend Montreal Protocol to get rid of substitutes of chlorofluorocarbon. That is a breaking news to all of you right now. Okay, 4:30 in the morning, I got a call at 2:30 in night from my colleague in Dubai saying that the world has agreed to set up a contact group to discuss phase down of gases called as hydrofluorocarbon, which causes global warming. And these gases are actually rapidly increasing because refrigeration, air conditioning, mobile air conditioning, aerosol, solvents, we are using these gases, refrigerants in these kind of products. Yeah. It depends whether you want to get a skin cancer or you want to get more extreme weather events. You decide. Essentially saying CFC will be a bigger devil because it caused global warming but as well as ozone hole. So CFC also had global warming potential. Okay, they were the lesser, bigger devils, both ozone hole and global warming. But HFCs they have less ozone hole potential, ozone depleting potential, but they have huge global warming potential. But the fact is, and it is important for all of you to understand, and I'm sure Marcus is going to talk about it, that when the world was phasing out CFC, we had technology which was non-global warming and non-ozone hole depleting. And that were the first refrigerants. Actually, carbon dioxide is a great refrigerant, okay, in certain application. A lot of hydrocarbons are great refrigerant, but there was a lot of multinational interest which moved us from CFC to HFC, and I'm sure Marcus will touch on those issues. Let me come back to the politics. This was a little bit of science for all of you to understand what the panel is going to talk about. the politics is between survival emission and luxury emissions. How do you compare black carbon emissions from cook stove of a poor woman in tribal India to a rich Indian driving sports utility vehicle? Okay, one is a survivable emission, another is a luxury emissions. That needs to be understood. Okay. Second is, lot of opportunity and co-benefit of short-lived climate pollutant is in our part of the world. Okay. So the politics is that why doesn't developing country do short-lived climate pollutants so that we have time to address carbon dioxide? Okay. So we will not act on carbon dioxide right now. Let developing country do short-lived climate pollutants right now because their people are also dying because of black carbon. So it is a co-benefit agenda for developing countries, and you will hear this word a lot of time, that it is co-benefit agenda for you to get rid of black carbon because Delhiites will die less because of respiratory diseases, and it will also solve climate change, and it will give us a little more time to emit carbon dioxide till we find some utopian solutions. Okay. So the politics is between short term and long term. Okay. And that politics has to be understood because we are likely to get, convinced by that politics. But as I showed you that graph, any delay in carbon, short-lived will give us some benefit. But we cannot delay action on long-term pollutants like carbon dioxide as well. Okay. And therefore, shifting the focus away from CO2, okay, which is the politics of short-lived, is not good. We need simultaneous effort both on short-lived as well as on long-term climate pollutants. And one of the suggestions that CSE has is maybe developing countries should look at short-lived and developed countries should look at technology for CO2, okay, because CO2 is their major pollutant, okay, whereas short-lived in many ways is a significant pollutant in many parts of the world. So if there is a trajectory to take action, maybe developing countries start with short-lived and developed countries do long CO2, which is also expensive to solve. Okay. So let me end here. I will now invite Asha to come and your presentation. Okay. 15 minutes and then few questions, then 15 minutes. That's how we are